Chapter 9, Control Stand Manufacture and Assembly.
The materials used. You'll need 4 2-foot by 3-foot galvanized flat sheets, 8 1.5-inch steel corner braces, some 3/4-inch galvanized roofing nails, 16 5/16 by 1.5-inch fender washers, a 10-foot length of 3/4-inch steel EMT conduit, a 10-foot length of 14-gauge half-slot channel, 8 3/4-inch universal pipe clamps, 2 3-inch door hinges with half-inch screws, a 4-foot by 8-foot sheet of half-inch plywood. Some nuts and bolts. You'll need 10 2-inch 5/16-inch bolts, 2 4-inch 5/16-inch bolts, and 1 6-inch 3/8-inch square U-bolt. 12 5/16-inch lock nuts, 2 3/8-inch lock nuts, and around 40 wood screws. You'll want a 12-inch by 17-inch irrigation box, a 12-inch by 12-inch PVC junction box, a garden hose splitter, 3 3/4-inch female hose thread to 3/4-inch male pipe thread swivels, and a 3/4-inch male hose thread to 3/4-inch male pipe thread adapter. 2 3/4-inch electric water solenoids with inline flow control, 8 hose washers, about 2 feet of 14-gauge steel picture hanging wire, and a Horto domi electronics package. The tools used, we used a 4-foot T-square, Sharpie, pencil, circular saw, a chop saw, a hammer, pair of scissors, a Dremel with some cutoff wheels, a 1/2-inch wrench and a 1/2-inch ratchet, a screwdriver, and a hand drill with a 3/8-inch bit, 7/16-inch bit, 1-inch hole saw, 1 3/4-inch hole saw, and 2-inch hole saw.
We will be making a cabinet for the fertilizer out of plywood covered in steel sheeting. Casey will be using a circular saw to cut 6 pieces of wood for the cabinet. The first row of pieces will be 20 inches wide. The first piece will be 22 inches tall, the next 16 inches tall, and the third 6 inches tall. There will be about 4 inches of scrap left at the top. Next we have the cabinet's sides, which have an additional edge for the lid to rest on. Their backs are each 22 inches tall, so they line up evenly with the panels drawn in the first column, one being 22 inches tall, and the other two, 16 and 6 inches, add up to be 22 inches. So then one just measures in an additional 19.5 inches for their depth, or that the second column is 19.5 inches wide. Their tops share the same line for 5.5 inches before taking a 3-inch fall over the next 14 inches, leaving a 16-inch edge. The 3-inch fall has dropped the height of the front of the cabinet to 19 inches, with the final piece being 19 inches by 19 inches. Next, use the corner braces to frame the cabinet. The large pieces in the back and the 2 sides sit in front of it, making their depth of 19.5 inches combined with the 1/2-inch width of the plywood a cumulative 20 inches, while the front piece sits inside the 2 side walls, making its width of 19 inches combined with the 1/2-inch widths of the 2 side walls a cumulative 20 inches. The 6-inch piece sits on the top and needs to be braced securely, as this is the piece the door hinges will attach to. Put some wood screws down the edge of the cabinet for reinforcement. If you're as messy as me, using whatever length screws you've got, now would be a good time to clean up, cutting off any excess, leaving a clean surface to lay sheeting on. I'm using a rotary tool with a cutoff wheel. I installed and removed the hinges just to make sure the door fit properly. I might be adding a step here, but I wanted to pre-drill my bolt holes and various portholes before I covered the cabinet in steel sheeting. I will end up coming back and drilling through the steel sheeting in the exact same location, but of course it's very easy at this point as the wood has been pre-drilled. That being said, the delay of this step is up to you. I used the 14-gauge bracket as my bolt hole guide. I placed one rail flush at the bottom of the cabinet, the unpolished end butted to the left side, and then marked a center hole 2 slots in from the left and 3 slots in from the right. I did the same, but approximately 2 inches down from the top, or as close as I felt I could go, and use my fender washers on the inside. Next, I'm going to drill a pilot hole for the earthworm T reclamation port. This hole is about 7 inches from the rear of the cabinet and about 1.5 inch from the bottom edge. Next, I'll drill a pilot hole for the fertilizer outlet port, centered on the top board of the cabinet, 3 inches from both the top and the bottom, and 10 inches from each side. After drilling both pilots, I then switch to a 2-inch circular drill bit for the top port, and then to a 1-inch circular bit for the earthworm T reclamation port. Finally, I switch to the 3/8 inch bit to drill the bolt holes. This was my first time using sheet steel to cover wood like this, and there were so many things that I learned and would like to do differently that I hope you'll forgive me if this section is more about how it should have been done than how it was done. I figured my sheet measurements to be 2 18-inch by 22.5 inch, 1 24-inch by 24 inch, and 1 20-inch by 29.5 inch. I improperly calculated 29 inches the first time around. And don't even cut the 24-inch by 24-inch. It was just wrong. Just leave the sheet uncut. After drawing the 4 sections on the 3 sheets of 2 foot by 3 foot galvanized steel flat sheet, I used my heavy-duty scissors to cut them all out. I decided to start this learning experience with the rear of the cabinet, and thus the least seen, just in case it didn't go so well at first. Taking the galvanized roofing nails, a hammer, and the 20-inch by 29-inch sheet of galvanized steel, I again, with visibility in mind, start on the underside of the cabinet, tacking the sheet flush to the 1/2-inch thick base of the board. After a handful of nails, and once I'm sure the sheet is securely attached, I begin to make a crease in the metal, working it over the edge of the board underneath it. Working the sheet over the top of the cabinet, it didn't take me long to figure out I either calculated incorrectly or this flat sheet managed to fight a 1/2 inch away from me. And it turns out that I mismeasured, likely not accounting for one of the board's widths. It should have been 29.5 inches. Also, if I were going to do this again with a 29.5 inch sheet, I think I'd like to start at the opposite end, placing my first tacks at the front of the top board, under where the lid sits, shaping the sheet back and to the underside. In either case, work the sheet metal over the wood corners, tightening the crease with your fingers and shaping and leveling the edges with a hammer. Once the sheet has been shaped down to the next relative plane with the board it will be nailed to, start tacking it into place. Something I found annoying, and can't say I really figured out a way around, was that when I was starting to nail through the sheet metal, just before it was going to sink into the wood, the nail would spring out of the hole. The tip of the nail would be going into the wood just enough that it would stay buried after I brought my hammer up, but the spring of the metal was enough to pull the nail free shortly after, projecting it sometimes, who knows where. Next, I tacked the 18-inch sheets to the sides. Make sure to wrap at least 1/2 inch around the back of the cabinet to cover that corner. Once the piece has been nailed into place fairly well, I'll use my scissors to cut a less than 1/2 inch slit just after the top board ends. Now this sheet metal can be shaped into the cabinet. I must admit, I wasn't paying attention on this front sheet. I know I'd thought the process out properly once, with it not involving my cutting the front sheet, but for some reason when I calculated trimming off the excess, I came up sorely lacking. I had another uncut flat sheet available, but it was going to be used to wrap the lid, and the 24-inch by 24-inch wouldn't do that properly either, so I just committed to my miscalculation, having to correct the mistake with the scrap metal I'd actually taken the time to measure and cut off. If I was paying attention, I would have been done by now. If I was to redo this step of the manufacturing process, I wouldn't cut the front sheet more than the cutting of slits along the edge to form the corners better. I would mark the 36-inch sides, 8 inches from each side, leaving 20 inches centered. After checking to make sure that this is the same width at the bottom of the front of the cabinet, I would cut 1/2 inch slits on those marks and begin to tack these tabs along the underside of the cabinet, focusing on laying the front of the cabinet first before folding the sides back, wrapping them under, and then finally cutting approximately 4-inch slits down the front corners of the sheet, folding the rest of the metal into the cabinet. However, it all worked out fine in the end. I just wouldn't recommend giving yourself any extra work is all. And don't forget to wrap the lid. You have the hang of it by now, so wrap it like a present to your own skill level. If your brakes are tight, then you'll only need to give yourself an extra ½ inch on the edges, and I gave myself a little bit more than that.
Using a metal chop saw, cut the 10-foot length of 3/4 inch conduit into 4 equal 2.5-foot lengths.
Again, when cutting bracketing, for uniformity, it is important to cut lengths on centers between the holes. I'm cutting lengths approximately 42 inches long off the ends of the piece, so I get the benefit of both of the polished ends. Also, earlier, before I had the camera rolling, I laid the bracket against the irrigation box as well to determine good mounting holes for it. I sat the bracket against the irrigation box on the construction surface. I placed the polished end even with the beginning of the box corners rounding, so that the rail didn't sit away from the box. Next, I marked a spot in the center of the first hole in the bracket as well as the 5th hole down, approximately 10 inches from the first. I don't bother with pilot holes in the soft plastic and move straight to the 3/8 inch bit. Next, I drill the portholes leading from the irrigation solenoid to the fertigation mixing vessel. This porthole is located on the left corner when facing the box from the direction in which you just drilled the 3/8 inch bolt holes. This corner of the irrigation box will be located nearest to the rear of the fertigation cabinet. You can start your 1-inch hole anywhere from 2.5 inches to 3 inches up the corner ridge. In my case, I found it easier to place the center of my hole at the top of this box's reinforcing plastic ridge, so I wouldn't have to fight with it to stay centered. Once the porthole is drilled, make sure the 1-inch pipe fits through it easily. Alright, let's put this box on rails. If you haven't already gone back with your 3 cabinet hole bits, the 3/8 inch, 1 inch, and 2 inch, and cleared the metal sheeting from the pre-drilled sites, please take care of that before you move forward. I've been talking about putting the unpolished ends of the bracket length behind the cabinet because the bracket sticks out much more on the other end of the control stand, so it just makes more sense to me to tuck the rough cut back and away. Slide a couple of 5/16 inch fender washers into the bracket before sliding a bolt through the washer, bracket, and cabinet. Secure the bolt on the inside of the cabinet with another fender washer and a lock nut. Make sure the end of the bracket is flush with the side of the cabinet and isn't protruding. Of course, repeat this step 3 times, securing the bracket lengths firmly to the cabinet with your 1/2 inch wrench and 1/2 inch ratchet. Follow the same procedure for mounting the irrigation box. Slide a couple of the fender washers into the bracket, then slide a bolt through the washer, bracket, and irrigation box before securing the bolt with another fender washer and a lock nut, using the wrench and ratchet to tighten to a point of stability, while not taking advantage of the box's shape and flexibility to over-tighten. You'll be putting 2 more stabilizing bolts into the irrigation box soon, so these 2 don't need to be tightened any more than to the slightest tension. Now we're going to begin attaching the vertical links of the 3/4 inch conduit to the bracket rails using the universal pipe clamps sold adjacent to the bracket, which itself was sold adjacent to the steel conduit. These first 2 beams are going to be used to mount and stabilize the fertigation mixing vessel. If you've been paying attention to uniformity, the holes in your bracket should still be in line with one another, making proper vertical alignment with just your eyes much easier. Place the first beam just past the edge of the cabinet. You'll be running a U-bolt through the conduit, so you should imagine how much space away from the cabinet you'll be working with a 3/8 inch nut and bolt. Not more than 1 inch, of course, but place the next beam 6 inches further down. The slots in my rail are centered every 2 inches, so I place my second beam in the same relative location 3 spaces down. Once they're both in place, make sure to tighten the universal pipe clamps. Now we're going to put the fertigation mixing vessel in place. The upper and lower have not been glued together yet. Once the mixing vessel has been put in place, a number of variables can be solved. With a temporary length of 1 inch PVC pipe, approximately 4 to 6 inches, sticking out from the bottom of the mixing vessel, place the vessel between the 2 beams and against the back of the top bracket. Next, slide the temporary length of 1 inch PVC into the port in the corner of the irrigation box while sitting the elbow in on the top of the bottom bracket. Since the placement of the mixing vessel is temporary, as it will be detached to finish gluing the last couple seams, I settled for the temporary solution of wiring the vessel into place. Once the bottom of the mixing vessel is properly situated, entering the irrigation box at a 45-degree angle and stabilized against the beams, you can make the minor shifts and adjustments of the upper mixing vessel necessary to better align it with the bracket and the rest of the stand. Once everything looks in line, take a Sharpie and mark a line down the double T and onto the 2-foot 3-inch chamber, just in case something shifts without your noticing before you glue it. Variation in the size of solenoids and plumbing attachments is great enough that I intentionally leave some elements unmeasured until they're in place. I did cheat a little, however, by putting my solenoid and irrigation set together earlier when I was drilling portholes in the irrigation box, so I already drilled the water attachment port earlier. Sorry, this was my first time, and I wanted to make sure everything was going to fit. Connecting the solenoids and irrigation is easy. Before you even begin assembling, make sure to add an additional hose washer to all of your connections. I've regretted any time I haven't. Connect the 3/4 inch hose splitter to two 3/4 inch hose to 3/4 inch male pipe swivels, and thread those into the inlet ends of the solenoids. The left solenoid will be going to the earthworms and only needs the 3/4 inch male pipe thread to 3/4 inch male hose thread attachment threaded into the outlet end of the solenoid. The solenoid on the right is the bed irrigation solenoid, to the outlet end of which we connect a 3/4 inch male pipe thread to 3/4 inch male hose thread swivel that can then be connected to the initial inline check we glued earlier in the fertigation system chapter. Once the solenoid and irrigation pieces are properly placed and tightened properly, place them into the irrigation box. This is when you will determine the proper location to drill your main water port. The inline check should be in line with the temporary piece of 1-inch PVC pipe from the bottom of the mixing vessel, which should be entering the irrigation box at a 45-degree angle. Ideally, the earthworm solenoid connection point would also hang out of the left side of the irrigation box, while the narrow portion of the Y-splitter's neck sits under the front edge of the irrigation box, the female swivel protruding. When all of these elements are as aligned as possible, that's the spot you mark to drill your hole. Drill your porthole centered over that mark, at least 1.5 inches up. I drilled 1.75 inch hole. Now that your irrigation can sit in place, you can measure for the appropriate length of 1-inch PVC pipe leading to the mixing vessel. My length happened to be an approximate 6 inches. Now we can attach the other two conduit beams. The third beam sits a little less than 7 inches from the second beam and ends up having to sit against the right side of that irrigation box bolt in the bottom bracket. The last and outer beam sits just over 13 inches from the second beam and actually sits right on top of that irrigation box bolt in the bottom bracket. The reason I measured over 13 inches from the second beam is because it's the second and fourth beams that actually support the electrical and router boxes. Now place an empty 1-foot outdoor box in place to make sure that the provided bolt tabs are centered over those beams, and then adjust to fit. The third beam is to be as close to centered between the second and fourth beams as possible, to be a backstop to each of the outdoor boxes, as well as a point of stability for the irrigation box. Once the beams are in the appropriate places and the box's placement lines up properly, mark the bolt hole locations to be drilled. Another reason I use the actual boxes to mark the bolt hole locations is because some of the bolt tabs are at uneven heights, such as on these boxes. When marking the electronics box location on the front of beams 2 and 4, I actually let the box rest on the top of the bracket in its position. You can also mark the mixing vessel beams at any time to receive the 6-inch U-bolt. I ended up placing ours about 1 inch above the cabinet. Now that the second and fourth beams are placed and marked, center the third beam between them. All the beams are in place, so now you can mark points for upper irrigation box support bolt holes to be drilled. The holes can be marked as far up the side of the irrigation box as you can, while still being able to place a fender washer on the inside wall of the irrigation box, basically at least 1 inch from the nearest opposing surface, such as the inner lip of the box. Mark the hole locations directly in front of the third and fourth beams. Once the height has been chosen on the box, mark the same height on both sides of the third and fourth beam.
Now you can drill a 3/8 inch hole in all of your pre-marked locations on both the irrigation box and the conduit beams, except for the two 7-inch from the top holes marked on beams 1 and 2. Those need to be drilled 7/16 inches in order to receive the 3/8 inch U-bolt.
Slide two 4-inch by 5/16 inch tap bolts through the third and fourth beam as well as the irrigation box before being secured on the inside of the irrigation box with a fender washer and a lock nut. Like before, don't take advantage of the irrigation box's flexibility when tightening, making sure not to tighten any more than puts the slightest amount of tension. Now would be as good a time as any to remove the mixing vessel to finish gluing the double T into the correct location at the top, as well as gluing the appropriate 6-inch length of 1-inch PVC pipe into the base of the elbow. Again, this is something I did out of order to make sure everything would fit properly. After giving the completed mixing vessel an adequate amount of time to dry, replace it on the control stand with the temporary wire and move on to the next step in manufacture and assembly. If you're manufacturing and assembling in place, you can go ahead and glue the other end of that 1-inch PVC pipe coming from the mixing vessel into the outlet end of the 1-inch inline check. We were moving the manufactured control stand from Austin, Texas to Factory Farm near Maysville, Missouri, so I saved this step until the final installation chapter. I attached the 6-inch square U-bolt across the mixing vessel and through the first and second beams. Now I'll attach the router box to the back of the beams number 2 and 4, securing them with 5/16 inch bolts with a lock nut on the opposite side of the conduit. Attach the electronics box to the front of the beam, number 2 and 4, in the same fashion, sliding a 5/16 inch bolt through the bolt tabs and the conduit before being secured at the opposite side by a lock nut. Now we're going to make a collar for our main water connection swivel. Take a rectangular piece of scrap sheet metal, approximately 9 inches by 5 inches or a little smaller, and place it on the outside of the irrigation box where the porthole is, long edge down. Mark the center point along the bottom edge. Next, bring the irrigation swivel through the port and press the narrower portion of its neck down across the edge of the irrigation box port. Note how high the top of that narrow section of the neck sits, and mark the length above the center mark on the sheet metal. Also note the width of that narrowed section on the swivel and measure the center distance on either side of your center line, marking a narrow channel up with a round peak. That will serve as a guillotine-style collar for the swivel once it's screwed in place. And that concludes the control stand manufacture and assembly portion of this DIY Horto domi instruction.